Students, welcome to Learner's Planet, our theory session 7 of metals and non-metals. Now, till now students, we have discussed about the chemical properties, the physical properties of metals as well as non-metals. Now, in this session, we will be discussing about the methods employed for the extraction of metals from its ores. Now the metals are they are very reactive, few are moderately reactive and very few metals are least reactive. Like the highly reactive metals are sodium, calcium, aluminium, potassium. The moderately reactive ones are your lead, iron, zinc, tin. And the least reactive ones are mercury, copper as well as gold. Gold is the least reactive metal. So, in this session, we will discuss about the processes employed for their extraction. Now, students, your metals which are active or which are reactive, they exist in nature as their compounds. Now, these compounds are associated with some impurities. Impurities which may be your rocky impurity, or it may be sand or gravel or any other chemical element. Now we need to, if we want to extract a metal from its ore, so there has to be certain process which is used to remove all the impurities. Now remember, there are only few minerals from which metal can be extracted. So we can say that all minerals are not ores, whereas all ores are minerals. That is what? That is the minerals from which metal can be extracted are called as ores. So we will start our discussion with some of the important ores of metals. Like here, there are some important ores of metals given. Like zinc. Zinc is a moderately reactive metal. Now it exists in nature as zinc sulfide, which is called as zinc blende. It can also exist as zinc carbonate, which is called as calamine. Iron, likewise. Iron is also one of the most important metals. It exists in nature as Fe2O3, that is hematite. Fe3O4, the name of this is magnetite. And FeS2, what is its name? It is iron pyrite. Your lead. Lead occurs in nature as lead sulfide, or it is galena. Lead sulfate, its name is what? Andesite. Likewise, copper. Copper is present in nature as copper pyrites. That is, what is the formula of it? CuFeS2. Copper carbonate, copper hydroxide, it is what? Malachite. It is basic copper carbonate. Now students, the minerals from which metals can be extracted are called as what? Ores. There are few more ores like your mercury. Mercury exists in nature as mercuric sulfide, and it is what? Its name is cinnabar. Silver. Silver exists in nature as silver sulfide, that is argentite or silver glance. We have got silver chloride, which is what? Horn silver. Then is your gold. Gold exists in nature as a free metal. Why? Because it is least reactive. Now let's move to metallurgy, or what is metallurgy? The various processes involved in the extraction of metals from their ores, followed by refining of metal, are known as metallurgy, right? So these are the processes involved in the extraction of metals from their ores. The processes used for extraction varies for different metals. How? There is the metal, it varies from metal to metal. If it's more reactive, the process would be different. If it's less reactive, we'll employ different process. So the processes for the extraction of metal varies from metal to metal. Now the three major steps involved in the extraction of metal from its ore are? What is it? Concentration of ore or enrichment of ore? It involves removing of all the insoluble impurities. Then is conversion of concentrated ore into metal oxide. Then your third step is refining of impure metal. Now let's start with the concentration of ore. It is also called as dressing of ore. Now students, this is the flow chart of metallurgy. First of all, there is what? The first step is the concentration of ore. The physical methods and the chemical methods. Physical methods, what are they? It is magnetic separation, hydraulic washing and froth flotation. Now students, the physical methods depends on the differences in the physical properties of the metal there and the impurities. Depends on the difference in their specific gravities or their magnetic character. Now it can be also concentrated by chemical methods like leaching. Now what is done? We have got a concentrated in our hand. Our second step is what? It is the conversion of concentrated ore into what? Oxide. Because it is easy to reduce an oxide rather than a carbonate or a sulfide or a sulfate. So the conversion of concentrated ore into oxide is done by what? Is done by roasting or calcination. Now after this, what we have got in our hand is the oxide. Now that oxide is reduced. How? By heating it with carbon, carbon monoxide or aluminium, or even by electrolysis. Now students, the metal which we will obtain from here will be 99.5% pure, or we can say it is 99% pure, but still there are certain impurities. Now they are done by refining it. How can it be refined? By liquation or electrolysis again. Okay. So this is liquation is again written here. That is not required. So there are so many processes, students, like there is zone refining is one, Von Arkel process is one. So these are all the processes which are used for refining metals. Now let's start with concentration of ore. So concentration of ore or enrichment of ore. Now how it is done? Concentration of the ore is also known as dressing or enrichment of ore. Now your ore usually contains soil, sand and material as impurities. Now these impurities are called gangue or matrix. Now the substance added to the ore to remove insoluble impurities as fusible material is called what? Flux. The fusible material formed during the reaction is called slag. Now students, the impurities like soil, sand and rocky material, they can be removed by the processes like magnetic separation, like hydraulic washing, like gravity separation, because their separation depends on the differences in physical properties. But there are certain impurities which cannot be removed by these processes. Say for example, if I am taking iron ore or if I am taking copper pyrites. Now what is the formula of copper pyrites? Copper pyrites. What is its formula? It is CuFeS2. Now students, here after oxidizing it, there is the impurity of iron oxide. Now how can we remove this ferrous oxide? There's no method. So what is done is, to this some silica is added. So your FeO, right? To this some silica is added, that is SiO2. As the result of which what will happen? Your FeO will react with SiO2 and will form what? It will form FeSiO3. That is, it is ferrous silicate. Now this ferrous silicate will get deposited at the bottom and it is then collected later. So got my point? So the impurity of iron oxide or the ferrous oxide will be removed out as what? Ferrous silicate. Now what is called flux here? Your SiO2. SiO2 will be what? It is flux, right? That is a substance added to. This should be insoluble. I'll write it as infusible material rather than insoluble. It should be infusible material. To remove infusible. Oh my God, this won't be visible enough to you. Infusible material. So this is what? This is flux. That is, what is flux? Which is added to remove what? To remove a ferrous oxide. And the substance which is formed is called as what? Slag. So why is your flux used? Flux is used to remove infusible impurities as fusible material. Now let's take up the process. Yeah, it is. The processes used for removing gangue from the ore are based on the differences between the physical or chemical properties of the gangue and the ore. What is done? The first step should be, what should be the first step, students? It should be the crushing of ore into powder. Why? Because you are getting ore in the form of a lump. Now that has to be crushed into powder. So at first the ore is crushed to powder. The next step is the pulverized ore is separated by physical processes like gravity separation, froth flotation and magnetic separation. Now let's take up these processes. The first step process is gravity separation. As the name indicates, the ore or the metal and the impurities will have different specific gravities. Now what is the principle behind this? The separation is based on the differences in specific gravities of gangue particles and ore particles. So what will happen? The particles like your soil or pebbles will have what? They'll have less weight or they'll have less specific gravity. The powdered ore is agitated with water. As the result of which what happens? The heavy ore particles settle down while lighter particles of sand, clay are washed away. So how it is done? See, this is the separator, the gravity separator. What is taken in this is the ore. What is it? It is a suspension of the ore. And powdered ore is poured from here. Now, this particular thing is what it is done to this. It is agitated. And fresh water is passed from here. So as a result of agitation, what will happen? The lighter particles will move out and the heavier ore particles will settle down. So, from here what we can get? We will get the concentrated ore from the bottom, whereas the lighter particles will move out. So this is what? These are the gangue or the lighter particles. So this is your gravity separator. There is one more method, that is which is called as hydraulic washing. Now what is done in that is, students, a sloping earth is taken. It's like this. Now your ore particles the pulverized ore is placed here, and from the top water is forced there. So a jet of water is poured from here. Right? Now what will happen? That which are the heavier ones? The heavier particles here. From here the water is poured here. Now which are the heavier particles, students? The heavier ones are the ores or the metal particles. But your lighter particles, that is the sands or the pebbles, they move out and they are collected. So what are these particles? These are gangue. And what will be settled here? It would be your ore or the metal. So this is also called as hydraulic washing. This is also called as hydraulic washing. So this is also based on the differences in the specific gravities. I hope you understood this process. This is nothing, just you can imagine there is a lighter particle and a heavier particle. The heavier one settles down, whereas the lighter one flows away. Let's take up the next process here. It is froth floatation. Now what is it? This method is used for the concentration of sulfide ores. Now students, this method is specifically for sulfide ores. What is the principle behind this? The ore particles are wetted by oil, whereas gangue particles are wetted by water. It means what? Say, if I am taking this as the ore particle, so there will be the deposition of water molecules over it. So these are what? This is ore, so there will be deposition of oil particles here. So what is it? This is the ore. So there is the deposition of oil particles here, and this is your ore. Now as the result of which what will happen? This will become lighter and it goes up. Whereas your gangue particles, that is your pebbles or soil or gravel, now these are wetted by water. So these will be wetted by water. So what are these particles? These are water particles. Now this will settle down. Right? So this is your froth floatation, and what is the principle? That the ore is wetted by oil, whereas the gangue particles are wetted by water. The process. The powdered ore is added to water containing pine oil and is agitated vigorously. Now as the result of which what happens? Ores stick to the oil droplets and rise to the surface in the form of froth supported by air bubbles, whereas your gang particles sink to the bottom. Let's see how it happens. Say this is your process. This particular thing is ore plus water plus pine oil plus what? Sodium ethyl xanthate. Now why the sodium ethyl xanthate is added? Sodium ethyl xanthate makes the ore non-polar. Sodium ethyl xanthate sticks or prevents the interaction of ore with water. So there is ore plus oil, so that the ore is wetted only by oil. Then it is agitated by passing air through it. As the result of which what happens? The ore particles come to the surface. And this will form foam due to the presence of air. Bubbles stick to it. Now what happens next is that the froth is collected over water and the gang particles, they are collected separately. So from where we can get concentrated ore? We are collecting the foam or this foam in the another container. So there what happens that the ore particles leave oil because here there is less concentration of oil and they get settled at the bottom. So this is what? This is the froth flotation. And what is the principle? The principle is that the ore particles are wetted by oil, whereas the gang particles are wetted by water. So students, these are the two processes used for concentration or dressing of ore. In our next session, we will discuss about another process, that is the magnetic separation and extraction of mercury from mercuric sulfide, or the extraction of less reactive metals. So thank you students for listening patiently. Have a nice time ahead.